let's work out an example here. Let's find the arc length of f of x equals mx plus b from x1, y1 to x2, y2. Okay, so if f of x equals mx plus b, then that means that f prime of x is simply equal to m. So the arc length, s, will be equal to the integral from a to b. In this case, it's x1 to x2 of the square root of 1 plus f prime squared. Well, f prime is m, so this is just m squared, which is obviously the slope of the line, dx. Well, notice that this is just a constant. So this is going to be the square root of 1 plus m squared times x evaluated from x1 to x2. So I can evaluate this now. This is going to be the square root of 1 plus m squared. Again, this is just a constant. Times, evaluate x at x2, so it's x2 minus x at x1, x1. Remember, this m is a slope. And the definition of a slope, I can write this as y2 minus y1 over x2 minus x1 squared. See, that's m times x2 minus x1. Now, when I multiply this or bring it inside the radical, it comes in as being squared. So it comes in as being squared, it cancels with the denominator here, but I end up with it being squared over here. So this is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And there you go. That's the arc length. Now, hopefully you recognize this. This is nothing more than the distance formula. That's all that is. Well, that makes sense because this is a linear function. And I didn't specify it from, x equals 2 to 3, and I didn't tell you what m was, so we did it very generically. So since we did it generically, we better have come up with a distance formula. This is the distance between 2 points in R2. So this should have been exactly what you were expecting before we even started.